Higher-end cars typically come with alloy wheels rather than basic steel wheels covered with a hubcap. Called mag wheels because when they first came out they were made of an alloy of magnesium, today's alloy wheels are made of an aluminum alloy, which is far more durable. Aluminum alloy wheels are not only more attractive than standard steel wheels, they're also a fraction of the weight, and therefore require less energy to rotate. This contributes to greater fuel efficiency, as well as better handling, acceleration, and braking. Manufacturing them begins with high-grade aluminum alloy, containing 97% aluminum. A furnace heats the ingots to 750 degrees Celsius. They liquefy in about 25 minutes. The molten aluminum then flows directly to a mixer, in which they inject argon gas, which enables them to remove the hydrogen. This increases the density, making the aluminum less porous when solidified. After adding powdered titanium, magnesium, and other metallic elements to further strengthen the aluminum, they blend in flux, a chemical which draws aluminum oxide to the surface. They skim off this impurity along with the flux, and the liquid aluminum is ready for casting. The wheel mold is made of high-strength steel. It's actually a set of 3 molds: the upper mold, which forms the inside face of the wheel, the 4-part side mold, which forms the wheel's edge, and the lower mold, which forms the outer face. That's the side with the design, so this is the most intricate mold. It takes 3 to 4 weeks to produce a mold. Computer simulations check the flow and temperature of the liquid aluminum, factors critical for preventing casting defects. The casting machine is designed to fill the mold from the bottom by pressurized injection. Injecting upward through the bottom, rather than pouring downward into the top, reduces the risk of air bubbles, which cause defects. Right before casting, the molten metal flows through a filter sheet made of high-temperature resistant ceramic. This traps additional aluminum oxide. Once cast, the aluminum takes about 7 to 10 minutes to solidify. Then the mold automatically opens, releasing the newly cast wheel. Workers submerge it in lukewarm water for a few minutes. This cools it down enough to be handled. The wheel undergoes a complex heat treatment process that takes 12 hours from start to finish. First, they heat the wheel to 500 degrees Celsius. This rearranges the molecular structure, strengthening the metal. Next, what's known as quenching. They submerge the wheel in 80-degree water for 30 seconds. This locks in that new strength. Then they reheat the wheel, this time to 180 degrees for 9 hours, to further stabilize the metal. The wheel doesn't come out of the mold in perfect condition. The edges are rough due to some excess metal that has to be trimmed off. So they mount the wheel on a computer-guided lathe. It precision machines the sides, refining them to within 0.05 millimeters of the measurements specified in the technical drawings. As for the more intricate face of the wheel, a worker manually trims the edges with a blade. The shape now finalized, it's time to test the wheel to make sure it's airtight. While pumping air into the wheel, they submerge it in water. Should any air bubbles appear, it would mean there's a pinhole in the metal or some shrinkage, in which case the wheel would fail inspection. No air bubbles, the wheel proceeds to the automated painting line. First, a base coat, then a coat of color, which can be anything from classic silver or black to a flashier shade. Then a clear coat to protect the paint and prevent corrosion. From every 1,500 or so wheels, the factory randomly selects 2 or 3 to test for performance and wear. Workers install the decorative cap that covers the center hub. It typically bears the specific brand's logo. Then, a final cosmetic inspection to make sure these aluminum alloy wheels look as good as they perform.